Hello, class 7. In today's discussion of chemistry, we are going to see about the physical properties of oxygen. Physical properties are those properties which can be seen with our eyes or can be felt. We can feel it or see it or taste it. So, these are called physical properties. So, oxygen gas is colorless, so we can't see it. Okay, it's mentioned over here, it's colorless. And if you remove the lid of the gas jar in which oxygen is there and wave your hand to bring the gas molecules towards you, you will find it to be odorless also. Means it is of no smell. There is no smell coming from it. Thirdly, since the gas has been collected over water, downward displacement of water in the earlier section we had discussed, it is not appreciably soluble in water. Why do we use water in the downward displacement of water method? Because oxygen does not get soluble with water. Oxygen already has its share mixed with water. H2O is the formula of water, right? Hydrogen and oxygen. So oxygen is already there present in water. No more extra oxygen of the air gets mixed with water. So water is water does not mix oxygen with it. Okay. So solubility of oxygen in water is extremely important for fish. Already there is oxygen in water. So no more extra oxygen from the atmosphere will mix with water. Number 4, it is slightly heavier than air. Okay. Because of this property, we can collect oxygen as means you can invert the gas jar and keep oxygen in it. You can actually not invert, sorry. You can make the gas jar in upright position. It's actually like this. If this is the gas jar, okay, here's the gas jar shown. These are the molecules of oxygen. Now these molecules will not escape because they are heavier than air. They will remain down only. Okay, so this is the advantage of oxygen being heavier than air. You can keep the gas jar in upright position. Otherwise, no, you have to keep the gas jar in inverted position for those gases which are lighter than air, so that they don't escape in the air. Next, number 5. If you bring a litmus paper near the mouth of the gas jar of oxygen gas, you will see that there is no change in its color. Litmus papers are used to test whether a particular mixture or particular substance is acidic or basic. Oxygen is neutral to litmus paper. It does not produce any effect in the litmus paper. Hence, oxygen is neutral in nature. It is neither acidic nor basic. Number 6. Oxygen can be liquefied. When do you liquefy? When you can bring the molecules of any gas close to each other by applying pressure, or if you cool it, while cooling also the molecules come close to each other at a very low temperature, then you can actually liquefy any gas. So oxygen also can be liquefied, and once it gets liquefied, it turns into a pale blue liquid. Okay, and it gets liquefied at the temperature of minus 183 degrees Celsius. Okay, minus 183 degrees Celsius. At this temperature, it becomes liquefied. Next, coming to the chemical properties of oxygen. Number 1. Oxygen is a good supporter of combustion. You must have seen in villages when they burn wood to cook food, no? They have those chulha. So, to make the fire burn brighter, they take one long pipe and blow through that pipe in the fire. That makes the fire to burn brighter. So, oxygen gas actually supports burning. It is known as combustion. Okay, so any gas jar containing oxygen, if you bring a burning splinter or burning matchstick near to it, that matchstick will start glowing even brighter. So this proves that oxygen supports combustion or burning. Next, oxygen gas is a supporter of combustion, but itself it is not combustible. Oxygen gas, if you bring fire near to it, that gas will not start burning. It is not itself combustible, but yes, it supports combustion. It helps in the process of burning, but it itself does not burn. Okay, now coming to a very important discussion. Oxygen gas mixed with any non-metal like carbon, okay, oxygen mixed with carbon to produce an non-metallic oxide. Okay, non-metal plus oxygen gives non-metallic oxide. That non-metallic oxide, when you mix with water, it will give you an acid. So since that non-metallic oxide mixing with water gives an acid, so that non-metallic oxide is also known as acidic oxide. Similarly, sulfur, which is a non-metal, okay? So when sulfur is added to oxygen or it is burnt in oxygen, it produces sulfur dioxide. It is also a non-metallic oxide. Alright? So that non-metallic oxide, sulfur dioxide, when you mix with water, it gives you sulfurous acid. It's an acid. So this particular non-metallic oxide is also known as acidic oxide. So just know that any non-metal, when it burns in oxygen, it produces a non-metallic oxide which is known as acidic oxide. Okay. Similarly, phosphorus, it burns in oxygen to produce phosphorus pentoxide. It is a non-metallic oxide because phosphorus is a non-metal. And this phosphorus pentoxide, when it mixes with water, it gives phosphoric acid. Okay. All these are acids, so they will turn blue litmus solution into red. Alright, all these acids will turn blue litmus red, and since these non-metallic oxides reacting with water produces acids, so these non-metallic oxides are known as acidic oxide, whether it is phosphorus pentoxide or sulfur dioxide or it is carbon dioxide. They all react with oxygen to produce non-metallic oxides which are acidic oxide, and that acidic oxide reacting with water produces acid. Okay, then comes the next thing, metals. What happens if strong metals like sodium, potassium, and calcium are mixed with oxygen? Okay, heat a piece of sodium metal in deflagrating spoon. That means a spoon which is um, heated, and then just heat the sodium metal in oxygen, and then you see what happens. Metal, when it reacts with oxygen, produces metal oxides, which are known as basic oxides. Why they are known as basic oxides? Because that same basic oxide, when reacting with water, produces a base. Now, what are bases? Bases are hydroxyl ions of metals. Okay, so these hydroxyl ions, the compound that it is producing, these compounds turn red litmus solution into blue, indicating that it is a base. Acids turn blue litmus solution to red, bases turn red litmus solution to blue. So remember, metals with oxygen produces metallic oxides, which are basic oxides. These basic oxides, when added with water, produces base. Okay, similarly you have here calcium, when reacts with oxygen, produces calcium oxide, which is a basic oxide. This basic oxide of calcium oxide, when added with water, produces calcium hydroxide, which is a base, and this will turn red litmus solution to blue. Alright, same way you have potassium, when reacts with oxygen, produces potassium oxide, which is a basic oxide. This same potassium oxide, when you add water to it, produces potassium hydroxide. This potassium hydroxide also turns red litmus solution to blue. Okay, similarly, there are other metals apart from potassium, sodium, and calcium, like magnesium. It burns in oxygen. Okay, magnesium, it burns in oxygen. Here is a strip of magnesium. It is burning with a dazzling flame. Okay, when you immerse this burning magnesium into a jar of oxygen, see, again you see this jar has been kept upright because oxygen is heavier than air. No, it will not escape into air. It's heavier than air, so it will stay down. So as soon as this burning magnesium ribbon is introduced in the jar of oxygen, it starts burning even brighter. and the ash that it produces is magnesium oxide. It is white in color. Okay, so that magnesium oxide is also a metal oxide, so it is also basic oxide. Oxygen reacts with red hot iron, not normal iron, red hot iron, or you pass oxygen gas through red hot iron, then you will get iron oxide. Iron oxide also was obtained in rusting, remember? But rusting is a slow process. But in order to get immediately iron oxide, you have to pass red hot iron. That means iron which is heated to a higher temperature. And then when you pass it through oxygen, it produces iron oxide. In nature, it occurs as magnetite. This iron oxide is magnetite. Remember magnetite? It's a form of magnet. Okay, magnets which are existing in nature. Okay, this we already discussed. Next, we will learn about the uses of oxygen. Okay, the first use that is mentioned is oxygen in air is continuously used by human beings and animals for breathing. Without this oxygen gas, you won't be alive because you won't be breathing at all. This oxygen gas, it mixes with your blood and that is transferred to each and every cells in your body. Okay. Atmospheric oxygen is also being used up for burning purpose and for fossil fuels. No car, bus, train, aeroplane, scooter, bike would have been usable if the vehicle did not have fuel. Now, if it has fuel, that fuel has to burn. Who produces or who helps in burning process? Oxygen. So, unless the fuels burn, they will not produce that heat necessary to move the engine. The fuel produces that heat which makes the engine to rotate. Then only your car, bus, or whatever vehicle you have runs. So, it is the oxygen gas which helps in the process of burning or combustion of fuel. Large amount of oxygen, that is nearly 80% of oxygen, is prepared in artificial method and is used in the manufacture of iron and steel. Next, pure oxygen is used by deep sea divers, mountaineers, those who climb mountains. High up in the mountain, they have less air, no? So they carry oxygen cylinders. Sea divers, those who dive deep into the sea, carry oxygen cylinders with them. Okay, to breathe for a longer time. They cannot hold their breath, no? They have to take oxygen cylinders. So pure oxygen is used for this purpose. Hospitals also produce oxygen, and those who have difficulty in breathing, they are given this oxygen gas. You know, remember in corona time, many people had their oxygen levels down. They could not breathe properly, so they needed cylinders of oxygen. So it is used in hospitals for that purpose. Oxygen is used in chemical industry for making acids. Remember, oxides of non-metals, they are acidic oxides, and when mixed with water produces acids. So for producing those oxides, non-metallic oxides, oxygen is used. It is used in the manufacturing of steel. Okay, now this is interesting. You must have seen welding. Welding of metals, to join one piece of metal with other, we use a technique known as welding. In that, there is, here is the picture, okay? In that, there is a flame that is produced. That flame has very high temperature. You must have seen a person carrying like this instrument in one hand, and in another hand he holds a shield which he places in front of his face, because the radiation of light which comes out from this is very high. You cannot see it directly. So there's a shield of glass which the person holds in front of his eyes, and then with the other hand he starts welding. So this particular flame that is produced is not any ordinary flame. It's oxygen gas mixed with another gas called acetylene gas. Okay, oxygen gas from one side is supplied, and from the other side there is acetylene. This is also another kind of gas. These two, when they get mixed up, they produce extremely high temperature of 2800 degrees Celsius and above. Oxygen with hydrogen flame can give a temperature of 2800 degrees Celsius. But oxygen gas, when you mix with acetylene flame or acetylene gas, it produces even a higher temperature, see 3700 degrees Celsius. So oxygen, to produce higher temperature, instead of mixing oxygen with hydrogen, we prefer mixing oxygen with acetylene gas. That is called oxyacetylene flame. This particular flame is known as oxyacetylene flame. Here it is mentioned. This is producing very high temperature. It is used for welding purpose. Next, food needs to get mixed with oxygen. This is called oxidation of food. Your body has to be having enough of oxygen to convert the food that it stores in its cells into. Cells have food stored in them. That food has to get mixed with acid. Sorry, mixed with oxygen. I'm sorry. That food mixed with oxygen produces carbon dioxide, water, and energy. This energy is required by our body to do various kinds of work. Okay, so oxygen gas is necessary to break down food into carbon dioxide, water, and energy. Okay, in the next page, you see a very important table of differentiation given. First one is differentiation between combustion and respiration. Respiration is the process wherein we breathe in and breathe out. We take in oxygen and we breathe out carbon dioxide. Combustion is the process in which oxygen gas is needed for burning. Okay, so oxygen is necessary for combustion also, oxygen is necessary for respiration also. Combustion, the end products of combustion when it is formed, they are oxides. Okay, water vapor and heat. Okay, carbon dioxide, water vapor, and heat, and light also are produced when anything is burnt. Anything, whenever you burn anything, these are the end products that are formed. Whereas in respiration, what are the end products formed? Carbon dioxide, water, and energy. When you breathe out carbon dioxide along with water vapor present in the atmosphere, and energy, the heat energy. When you breathe out, you place your hand in front of your mouth, you will find that you breathe out heat energy also. Third, combustion, it is not a continuous process, okay, and can be carried out whenever we want. Whenever you want to burn something, then only this process of combustion takes place. But respiration is a naturally occurring phenomena. You cannot control it. Can you stop breathing? No, we have to keep on breathing, right? So it is a continuous process, respiration, whereas combustion is a non-continuous process and we can make it happen whenever we want. Next is it takes place at higher temperature, where for combustion to happen we need heat, extremely high temperature, whereas respiration takes place at body temperature. For breathing to happen we don't need to light a fire, no, it happens automatically in our body. Next is the difference between combustion and rusting. This one I'm not going to explain it. You can have a look at it from your book, or you can pause this video and have a look at it.